Welcome back to Abra Knowledge channel. Today we are going to discuss process capability for discrete data, and this is a follow-up video on type of discrete data. Yesterday in the previous video we talked about binomial distribution that is meant for defective data, and now it's a Poisson distribution that is meant for defect data. So to simply put, one defective unit can have a multiple defectives or multiple gray areas or defects and all that, right? And what is very interesting is in this video is we're going to compare U chart. Since we're talking about defect, we have only two choices. One is C chart or U chart. We're going to take U chart and we're going to compare with the process capability for Poisson distribution, right? There are two examples, one coming directly from the Minitab, another one coming from the book. Let me show you quickly the data. So this is the data which I'm going to take directly from the Minitab, and it is there within the Minitab that we're going to look out. And I have added one more column called total quantity we are going to discuss. And then we are also going to solve this question also as well. The number of non-conforming in the carpet is determined for 20 sample, but the amount of carpet inspected for each sample varies. I mean, the sample varies in each time. So a result of the inspection shown in the table, construct a control chart for the number of non-conforming per 100 meter per square. So we're going to take the as a constant sample and variable sample also. Quickly, we're going to do P chart and process capability. So this is coming from the book called, this is the book, as you can see here, Fundamental of Quality Control and Improvement, and Whaley publication, third edition. And the very sample data what I have, it is given in page number 391. The same data I have put it up in Excel, and we're going to achieve almost a similar chart like this. So let's go directly to Minitab. So this is the data. Let me just take a fresh sheet. Let me close all the file. Let me take the fresh sheet so that we can do it one more time. Okay. Okay. All you have to do is you have to go to file and open worksheet, and you will find look in Minitab sample data folder. Just select defect. So both are the same data. You can select defect, open. So this is the data has been there. These are different plants like Poly, Malvern, Exton, Jester, Devon, Reading, and so on. And this is the number of defects, and this is the describe of it. Describe about the defect. For example, dent, pore seal, O-ring, finish, and all that. We can also do a Pareto chart also as well, just to find out 80%. But we're going to do it more of U chart. We're going to see. And then this is the defect C chart. And if you wanted to do, let's say you also have a sample size that varies, then we can use U chart also as well. And more importantly, we're going to do process capability also as well. So quickly, we're going to do C chart, U chart, and process capability. There are three charts we are going to do. So what I will do, since it has old year data, what I'm doing it, I'm just replacing it with the current one. Let me go back to this one. I've slightly modified the data, very slightly modified the data. The same data, only the column, these three columns I have modified. What I will do, I will just copy these three columns as such. Okay, let me delete everything and then paste this data. Okay, let me go back and copy this entire data. I've not modified the data, just that, I have added these two columns as such, right? Okay, now we're going to do C chart. First of all, C chart is required count chart. Only one defective you have, only subgroups you have. You don't have the subgroups or the sample varies, then you can use that. We'll quickly do stat, control chart, attribute chart, and C chart. and defects, right? And then you can also give okay. This is basically a C chart. That means 28 in each cases, 28 defects we have. Let's say the same data, what I will do, I will group by, you can see here, I will group by plants, different plants name. So another one, for example, Exton, where it is there in the 50, 48 on an average is getting it. And the lowest we're getting it for this plant. And even lowest we can get it for this plant and all that. You can even you can do this also as well. Okay. So this is C chart. Let's say we have also have that sample also as well, right? The additionally we have a sample size also as well. So the choice what we have is U chart, right? Number of non-conformity per unit or per plants in this case. Go to stat, go to control chart and go to attribute chart and pick up the U chart. Monitor the number of defect per unit when the each item can have multiple defects. I'll give F3 and so variable, what is that? Defects, we can take it and divided by total quantity and U chart. I'm going to test all that 4 conditions, right? Give OK and U chart again and stages. I'm going to divide by plants. So now we have also got the U chart. That means 0.26, 26%. Each plant has got 26%. That means 1/4 has got defect, right? This is by group. Let's say you don't want group and you wanted to see overall, still you can do that. And all you have to do is you have to remove that stages. And this is without its stages. That means as a overall, irrespective of the type of the plants, each plant has got 14% of defect, 14.2%, and it goes up to 22%. It starts with the 6%, the middle is 14, and it goes up to 22. And there are outlier, and the process is not stable, and so on and so forth. This is all about U chart. The same thing we can do with the help of process capability. So what I will do, quality tools and capability analysis, Poisson distribution. Why? Because Poisson distribution is for defect and this is for defective. I'll give F3 and take this one defect. I'll take it subgroup is varies. Here we have a constant size 200 we have, and then start target. Let's say we want to keep it like 0.1. That means 10%. I'll give a test. I'll perform all 4 tests and options. Okay, we can give U chart for plants. Okay, and then storage, I'm gonna give a mean defect, mean DPU, minimum, maximum, and target everything, give okay. So what you find here is that this is a process capability, right? Process capability gives 4 chart basically, U chart, of course. Why it has given U chart? Because it's a defect. You can give defect and sample, so it is given 14.2. The same thing we have got here. Even if you see here, the same percentage we have got here. 14.2, 22, and 6, the same. And process capability gives additional information. It also says that if the sample is low, we get that up to how much? We get that 17.5% of defect, and then it goes on. And 95% confidence interval. So we have 28% of defects. Lower is actually like 25 to 31. And defect per unit, you have 14%, and you have a lower 12 and the upper is 15, right? And the minimum you will get like this and all that. And also DPU, this your target is here, but it is process is not stable. Even if you see that the expected defect or predicted defect, your observed value and expected one, as the sample size increases, your defect also increasing. So process is definitely not stable, right? So this is how we can easily conclude. So point example number 1, we completed. What I will do, I'll put all these things in one simple layout chart. What I will do, I'll go to editor, layout tool. So this is huge, I mean, process capability. And then I will take U chart. I'll C chart, I will keep it here. And maybe U chart, I will keep it here. And U chart by codes we have, right? We can keep it here. And I will just say finish. So now in a summary, example number one, the summary is first we did C chart. C chart is only if you have only defects, right? You don't have a sample, you have only defects, just to count. Then C chart you can use. Okay, U chart is an extension version of the C chart where you have a sample size, then you can use. The sample size can be constant, can be variable, doesn't matter. We can use U chart. And this U chart, as you can see here, these two are the same graph. What I will do, I will just edit it and I will remove this particular chart because this is a repetition. I'll remove this chart and okay, I will remove this. And instead of that, I will use just simply U chart. U chart, this is by plants. This is the U chart, I will keep it. And this also, I will just take it out because this is, instead of this, I can use C chart here. Yeah, this is better one. And I will give finish and then I will come back. Now I can explain the summary here. Okay, C chart is for only defect you have, and then U chart is an extension version of the C chart where you get the sample size, and then U chart 14.2. If you wanted to get entire details together, then you can use process capability. You can definitely do that. You get every information and histogram, not a bell curve because it's not a variable data, and you get everything. So this is example number one. I hope you find it useful. And let's go and do example number two also as well. Very quickly we can do it. Okay, you also have the fine here, and then I will take this data worksheet. And what I will do, I will just keep this, go back to this data. And what I will do, I will just copy this data. So the same example we are going to solve. Let me close this file. Let me open that. Okay, I will just close this one. This is fine. Okay. And now what I will do, I will just copy this one, copy this data and paste it in Minitab. So something is there which is not, okay, serial number. Okay, fine. So this is the data we have. Now what we can do, we can use the same thing. Let's say we have only defects, number of non-conformities in a carpet, right? So this is an example of carpet. So I will put like, yeah. So what I can do is start, and I'm going to use C chart straight away here. Okay, and then this is the C chart came up, and I'm not going to have any subgroup. So C chart, it has come here. That means the average nine, at least 9 defects we have in any sample you take it. That's what it means. And also this is going beyond the UCL. And this particular example number 7 has got 21. This is clearly not a stable process. Okay. And the same thing, what I will do, I will just use the U chart because I'm going to add the other column also as well. I'll give F3 and variable is that C3 divided by total inspected, amount inspected, okay, and give okay. So you can see here, because you have a variable sample, that's the reason it is coming like this. In the previous example is a flat one. So here you can see here, at least 4% of one you have a defective, right? Defects, right? And then the same thing, what I will do, last thing I will do it with the help of process capability, Poisson distributions. And so here I'll give F3. This is an opposite example. So number of defects, constant size sample. No, we have a different sample size. So I will put it this one. Let's say we want like only 5% defective, and test, perform all the tests and options. I can give U chart for carpets. And storage, I'm gonna give mean, minimum, maximum DUV, and target. Give okay. So now you see here, so the same information you see here. U chart, but process capability, and it gives you more information. What are the information? 4% and then 9%, but this particular one has got more than 9%. And then if the sample is low, the error is low. If the sample is high, the error is also getting high. And then this is irrespective of the sample high or low, but defect load, sample size and DPU, defect, how much defect you have, 4%, 6, 8, 10%. And this is a target, but you also have here all the values are also coming beyond the target also as well. So definitely the process is not stable, right? I hope you find this two example easy. Maybe what I will do, one last step, I will just put it together in the graph so that you can easily follow that. Okay. So, and the same thing you can see here, C chart we did it, and then I'll double click here, C chart, and then U chart we did it, and then we did that uh, process capability for carpets also, we did it. I hope you like this video. Please do like, share, subscribe my channel. You have wonderful day ahead.